Hello again, Nicole Mashburn, and today we're going to continue our discussion about membrane transport across a plasma membrane of a cell, and we're going to talk about osmosis today. So osmosis is a special form of diffusion. Osmosis is the diffusion of water across a selectively permeable membrane. So let's review quickly what was diffusion. So if we have our beaker from our previous discussion and we put a drop of color in it, the high concentration of color, that color or whatever solute you're trying to have diffuse is going to diffuse from areas of high to low concentration until it reaches equilibrium. Well, in osmosis, it's not the color that's moving, it's the water. So osmosis is the diffusion of water. So let's look at a membrane. Here we have a U tube, and you have a membrane, okay, that you're dividing this tube into two halves. So you have one half and you have two halves of this tube. And so this membrane is permeable to both solutes and water. So let's just say the solutes are these little red dots. That's whatever is in the water. So if the membrane is permeable to both, and you put an unequal amount of red dots in this side, you put less in this side than you do in that side, and then you walk away. Over time, this tube is going to come to equilibrium. Water's going to move in both directions, and the solutes are going to move in both directions because the membrane is permeable to both of these until they reach equilibrium. There'll be an equal amount of water and solutes on both sides. They've reached equilibrium. Now, cell membranes are not like that. They're selectively permeable. They only let some things cross. So if we have a selective permeable membrane and we put an unequal amount of solute, so we've got 1, 2, 3, 4, 5 on this side, and it looks like maybe 10 or 15 on this side, an unequal amount, what's going to happen? We want that to reach equilibrium. We want the concentration of the solute to be equal on both sides. Well, if the membrane is only permeable to water, the water moves. So what you'll see is this high concentration of solute basically pulls the water in this direction. The water is going to follow the solute or kind of chase the solute. So you're going to wind up with the concentration, this is the symbol for concentration, being equal on both sides. So you can kind of see that these red dots are equally dispersed on either side. There's more of them on this side, but they're in an equal concentration or relative distribution. So cell membranes are selectively permeable, okay? So the water molecules are going to diffuse across the cell membrane toward the side with a higher concentration. So the water moves to the area of higher concentration of solute. Okay, that's osmosis. So it's a special form of diffusion. So when you think of osmosis, we have to talk about osmotic pressure. And so osmotic pressure, this is going to become really important later on when we talk about the kidney infiltration. We're also going to talk about blood pressure. So osmotic pressure is something that we're going to introduce to you now, and we're going to kind of talk about it more and more as we move through your A&P course. So remember, in osmosis, the water flows toward the side of the cell membrane with the higher solute concentration. So if this is a cell, okay, and let's just say that we're talking about sodium. So there's a lot of sodium on right at really big outside and a little bit inside. So lots of sodium on the outside and a little bit of sodium on the inside. So something's got to move in order for you to reach equilibrium. You want there to be the same concentration on either side. Well, sodium's not going to be able to move because this membrane is selectively permeable. It won't allow the sodium to move, but water can move. So what happens is water will leave the cell. It will go from the low concentration to the high concentration, okay, and that cell is going to shrink. Now, let's imagine in this case you had a little bit of sodium on the outside and a lot of sodium on the inside. Again, the membrane is not permeable to sodium, but it is permeable to water. Water is going to go to the higher concentration, so water is going to go into the cell and cause it to swell. So a hard and fast rule in our class is going to be water follows salt, okay, or water follows sodium. Salts are not the only thing that influence osmosis. Other things do play a role, but you can always say water follows sodium. We're going to use that same analogy many times when we talk about the movement of water between compartments in the body. We're going to say, okay, where do you have the most sodium? Water is going to go to wherever you have the most sodium. And this drawing of water toward the higher concentration of the solute is called the osmotic pressure. And we say that osmotic pressure sucks, so it's the sucking pressure. It literally, a high concentration sucks the water across the cell membrane. Okay, so osmotic pressure sucks. So water follows sodium. And this is important in a real life situation. When you're thinking about if you're going to give someone an IV, you have to think about what happens if you put someone's cells in a fluid that's either too salty or not salty enough. And so we use the word tonicity, and for the ease of understanding at this point, you can just call this saltiness. Okay, so if something's isotonic, if you have an isotonic solution, iso means the same. That means the saltiness inside the cell is the same amount of, I'm going to put another color. If the saltiness inside the cell equals the saltiness outside the cell. So if that cell membrane is selectively permeable and blocks sodium, sodium can't move, but water can, water will just move back and forth and stay in equilibrium, and the cell won't do anything. It just remains normal. If you put this cell in a hypertonic solution, hyper means high, so it's more sodium on the outside. Hypertonic is more salty on the outside than it is on the inside. Again, this membrane is selectively permeable. The sodium can't move. Where's the water going to go? Well, the water inside the cell is going to leave the cell and cause the cell to shrink. So if you were to put someone's cells in a salty solution, they would shrink, and that could be fatal. So you have to understand tonicity when you're thinking about keeping someone's fluid balance regulated. And we'll do more and more of this as we move again through the class. Hypotonic. Hypo means too low. So this is a low salty solution. So if you put a cell in a solution that has a small amount of sodium relative to the larger amount of sodium inside the cell, what's going to happen? Water is going to be drawn or sucked into the cell, and the cell is going to swell and possibly burst. So this has to do with tonicity. And so we're going to talk about fluid and electrolyte balance. We must maintain our correct sodium levels in our body. We have to maintain the appropriate sodium concentration in our body, because water follows sodium, and so to become superhydrated or dehydrated a lot of times can have something to do with your sodium levels. You may have noticed if you eat a really high salty meal, all of a sudden maybe your rings, or you can't get your rings off, your fingers are swollen. You've got a lot of sodium in your body, and that's kind of holding on to the water. So water follows sodium and kind of causes your tissues to swell some. So think about this question. You will see a question very similar talking about putting a cell in a hypertonic or hypotonic solution on your exam. So make sure you understand this concept. Thank you for your attention.